Now, the data set that I'm looking at is one that you might be familiar with. It's to do with the performance of loans, where small businesses have taken out these loans. We have an outcome variable that is called Prism, which tells you how well the loan has performed halfway through its life. And we have a number of predictor variables. Loan type, is it an original or repeat loan? FICO score of the individual signing for the loan. And a couple demographic variables associated with the business. The business is in some zip code, and these two variables tell you the number of males and females in that zip code. Now, what I'm going to do is run the multiple regression and make a comment on the output. So what I'm looking for to start off with are the significance of the coefficients, and the significance of the coefficients are in the parameter estimates table. And if I look at the p-values there, I notice for both the male and the female population variables, neither is statistically significant. Now the question is, can you remove both of these variables simultaneously? The answer to that is no, because if these variables are collinear, that they are correlated with one another, it's quite possible that each disguises the effect of the other variable. And so when you have collinearity, correlation between the x's, it is possible that neither coefficient by itself appears statistically significant. However, taken as a bundle, viewed as a whole, they still add predictive power to the model. So what I want to do in this instance is to test the two variables, male and female population, simultaneously rather than one at a time through this t-test. So in order to test variables simultaneously, that's called the partial f-test, and it's implemented in JUMP through the custom test dialog. Now to run a custom f-test, you right click on the title bar, you go to estimates, and you're looking for custom test. So I click custom test. Recall, I'm going to be testing male and female population simultaneously. Now at the bottom of the output you have the dialog for the custom test, and the key thing to remember is that you need to have as many columns here as variables you are testing. And in this example I'm going to test two variables, male and female, therefore I'm going to add a column, and by doing so I now have two columns in the dialog. In order to carry out the test now, I simply have to specify which variables I'm testing simultaneously. So I'm going to type in a 1 on the male population variable to indicate that I'm testing that, and I'm going to type in a 1 on the female population variable to indicate that I'm testing that at the same time. So now that I've indicated the variables that I'm testing, remember that we are testing whether or not the coefficients are simultaneously equal to 0, we can click Done. After having clicked Done, you get some more output at the bottom of the screen, and the key information is sitting inside the box there. And what you're looking for is the prob greater than f. That is the p-value of the partial f statistic that has been calculated. Now notice here that the p-value is 0.128, and usually using the usual 0.05 cutoff, this p-value is larger than 0.05, and what that tells you is that you are unable to reject the null hypothesis. The null hypothesis here being that both variables taken as a bundle do not add any predictive power to the model. It says they're not any good. Therefore, based on the output of this partial f-test, it is legitimate to remove both of these variables at the same time.